we're going to start talking about our next segment, which is very important, align boring versus align honing, a tech feature.
Yep.
And, you know, the foundation of the engine in many ways. You think about the rotating assembly. If you get that wrong, well, it's not going to live. What are we going to see?
Especially with an engine like this, that's, you know, we want to make over 1,000 horsepower. We have no idea where we're going to end up in the end on how much power we make. We want to make a lot of RPM. We want to do a lot of power. Well, that geometry now, because the crankshaft is the backbone of the engine, and it's going to flex.
Yes.
So if it's already misaligned and it flexes, I mean, you got a bad day, just going to smack you in the face. So getting that aligned bore right is key, and that's obviously with the guys at Rottler. We've got the great F69 in the back where we're able to line bore. So they're going to go through and show us that difference between what is the difference between a line honing and a line boring, and how to get all that stuff right and what those compromises and trade-offs are. Because like you said, everything in engine building is a compromise to some degree, because, you know, I always say before, we're making soup, not steak. That's the key. It's like ring seal is soup, not steak. Really, engines are combinations, and you got to weigh all those decisions out. And of course, I'm not the smart guy here to talk about that. We got WJ and Kazi and all the real smart guys here later to really talk about that. But this is our little bit of a sneak at it.
All right, so if you were at the first Engine Performance Expo, you remember Embry, Herrick, of course, and Ed Kiebler from Rottler, and a little bit more of this guy. Let's check it out.
Hey everyone, I'm Ed Kiebler from Rottler Manufacturing. Hopefully you've enjoyed what you've seen so far today. This is Embry, Herrick, and Logan. They're from CNC Blockworks, and we're just going to have a discussion today about line boring. So we have an F69A behind us, and Logan and Embry have actually line bored this block. We're going to go over some of the do's and the don'ts, and maybe point out some things that I think would help you if you're also trying to line bore a block on a CNC machine. And then we're going to talk about a little bit of theory also, and what's behind it. So I'm going to ask Embry and Logan to chime in at any time here. But in essence, what we're doing here is we're setting a block on a V8 fixture, and it's a little bit of a unique fixture in that it's called a pivot table. And what we try to do is we line our rear main up right over the axis of the pivot, and then we'll use our machine and we'll dial indicate the rear main in, and then we'll move to the front main. And what we do is we have these two knobs, and this allows this table to actually pivot in and out and up and down. So it makes centering or aligning the block a much easier process than a typical situation to where you might be bumping the block or moving this or tapping that. So it makes it not only fast, but it also makes it very accurate. So what we're trying to do here is typically when we're line boring, we've either got a mismatch cap or we're putting 4-bolt main caps on that are undersized. And so we use the block to actually line up the main bore. So that's why we center off of the rear one and center off of the front one. And so now we're perfectly lined up, and as our right angle drive goes down through there, not only do we maintain size, but we maintain straightness. The size isn't your only issue on a main bore, obviously. We want the proper size for our oil clearances and such, but we also want alignment, because as we've all talked about in the past, you know, friction is horsepower, and any misalignment there is not only are we going to wear our bearings incorrectly, but we're also going to have more drag and more friction to turn that engine block over. Many of you that have rebuilt motors in the past, how many of you laid the crankshaft in there, you know, torque the center main, boy, it spins just great. Torque number 2 main, maybe number 4 main, and there's a little bit more drag on that crankshaft. Torque number 1 and number 5, and suddenly you go from a wrench this size to turn the crankshaft over to maybe a wrench this size to turn the crankshaft over. that's all about misalignment of the main bores. And so it's a very critical point of the engine to get that correct before we bore or deck or lifter bore or do any of the other things. So it's really one of our first operations in the process.
I agree with him on that. We've discussed it that that if you get the mains corrected, and even if you do have to drop the mains a little bit in the block, that if you're gonna build, and like I said in the past, we always use like the foundation. This is the foundation of the motor itself. So once we get the mains located and in that position, then we want to go to our next step would be correcting the cam. If we're going to put a 55 millimeter cam in it, and we move the crank up, say 2000s, just to correct the problem there, then we can actually take that option to move the cam up 2000s. Then at that point we go put the lifters in, oversized lifters or bushings, then we can put them to the center of the camshaft. So basically, in theory, we're perfect, everything top to bottom, and then the last thing would be the decking. So you got a truly what I call an old blueprinted block, because you know exactly where they are located.
Great point, Embry. And you brought up something that caught my attention is, and you said we'll drop the main bore down maybe a thousandths or two while we're line boring. That brings up an excellent point, because there are several ways to skin this cat, and anybody in the automotive engine rebuilding business knows that you can line hone the mains or you can line bore the mains. And in line boring, there's really two ways of doing it. You can use the old conventional style line bore with this big long bar in it, or you can use a CNC machine with a right angle drive on it. And just to point out a few things, we'll kind of jump back to the line honing aspect of it. Nothing wrong with line honing. It does a very good job. But I constantly talk to customers that struggle because you have a very long mandrel with 10 stones and 10 shoes in it. And you're trying to keep those 10 stones and 10 shoes perfectly true. Because if you don't keep them true and you don't have the proper overstroke, you are going to be big on one end or small on the other end. And it's a very hard thing to accomplish, to get something straight and to size within a few tenths. I was around line honing for 22 years of my career, and I think I was pretty decent at it. Wrote a tech paper on it and what have you. And on a very, very good day, when all the stars and the moons and Mars align, I might be able to hold 3/10 size throughout that bore. Normally, you're looking at about a 5/10 tolerance on a line hone. With this machine right here, and we can check this afterwards, but you're looking at 2/10. So we can really hold better size tolerance and all with this right angle drive line boring than you could ever do with a line hone. And again, not that line honing's bad. I have nothing bad to say about it. If you don't have, I guess, access to something like this, then by all means you want to line hone that block, because again, that crankshaft and that alignment of those mains is critical to making horsepower.
That's kind of like this block that we have in here now. It's an older 396, came out of a 66 Camaro. It is the original. The gentleman wants it to be basically blueprinted. Rare car, rare block. And I know it looks unusual in a high-performance place to have something like this, but the caps were twisted so bad from just conventional use over the years that we had to clip 5/1000s off the caps, then turn around, and then we just barely dropped it 0.5 into the block, but we had more control, and we've got 100% coverage, and we're at 2/10 from the maximum spec, and that's where I kind of like between 1/2 to 2/10 above the maximum specs is where I like to put names, especially on something on the street. So we have more control. If I had a line hone, and trust me, I love line hones too, because I've had one for 14 years. But if I had to clip the caps 5/1000s, the hone only knows one thing to load, so that means an average that it's going to take 2.5 out of the top, and it's going to take 2.5 out of the bottom. So therefore, we've created an extra 2,000 dropping of the crank in the block, which I would like to have more control over myself.
Yeah, that's a great point, Embry. You know, with this machine, what we can do is we dial indicate everything in, and then we can drop the center line by a half a thousandths or a thousandths just to clean up the block. Because when we're doing this right, you typically will just brush the block if we don't drop it a thousandths to clean everything up and make sure that alignment is correct. With a line honed, for every thousandth you reduce the diameter, you will drop the center line of the crankshaft 6/10. So we have better control over that center to center distance between our crankshaft and our camshaft. That's the main reason.
Well, the reason why that I'd say that it's important that you maintain the distance between the center of the crankshaft and the camshaft is if you get it too close together, then you're going to have a problem with your timing chain. You know, you're going to have excessive, there won't be stretch, but time you take a new timing chain, maybe add a little stretch to it, it's going to be running kind of sloppy there. And that's not very desirable, to be truthful. I mean, we've seen them come in where the timing chain has actually been kissing the cover, you know, with that much slop.
And don't you get a variation in timing that way
timing, yes.
when that happens?
Yes, when you go index it, you know, you have to play that in when you're indexing the camshaft in, if you've got that much excess. But we prefer not to. You know, we prefer it to be at the distance that it needs to be. That's the way it was designed from the factory, and those engineers are a lot smarter than I am. You know, so
yes, sir. So you know, we hear the stories. Well, I prefer a crosshatch angle in the block because it holds the bearing better. And my just blunt assessment of that is if you need the crosshatch angle to hold the bearing in the bore from spinning, you got bigger problems than that. And so, you know, we put a very nice finish on this, and we can vary that finish depending on our feeds and speeds. But to me, and Embry, you're the engine builder, but you know, the finer, the better the finish, the better heat transfer from the bearing.
yes, you need that. You would like to have 100% contact all the way around on the base of it. And the same thing with the crosshatch thing. People make that comment that I have to have cross. We've lost jobs because we don't line home. And I'm sitting there going, I'm giving you a better product, but you know, I don't have the crosshatches. And I was like, well, I can take a dingleberry hone and put in there and give you the crosshatch, but it's not going to make it any better than what we do.
Having been around line honing most of my career, and walking into shops, I get that constantly. As a guy will, you know, the rear cap will be small or the front main will be big or what have you, and you get guys that will break the torque to keep that one area from honing. Well, you're defeating your purpose. Again, you have to remember, it's not just size tolerance that we're looking for. We're looking for alignment, and alignment is critical. And I know a guy will say, well, you know, it doesn't make that much difference. Well, you know, it may not, but there's a proper way of doing it and an improper way of doing it. Doesn't mean that it won't run and make a bunch of horsepower and win some races, but there is a proper way of doing things, and breaking torque on a cap because one's getting larger than the other is not a proper way of doing things. We've put our block in here, locked it in place. We've actually indicated the rear main and the front main in. And when we indicate the rear one in, we zero our Y-axis and our Z-axis. And then we move to the front one, and we use our table to align that front bearing back up. Once we've established all of that, we're locked in now. And what we want to do then is we actually need to indicate our Y0 and our Z0. And I use a little trick because typically what we're using is we're using this small last word indicator, and it has you know, a certain amount of travel on it. And when you're trying to indicate a bore in, it's very difficult if that indicator bottoms out on one side and doesn't touch on the other side, and you spend a lot of time trying to get that thing centered properly to where you can actually get a reading, you know, 180 degrees apart. So I learned a trick from a gentleman a number of years ago, but it's the old business card trick. And so what you would do with this is you'd actually lower this right angle drive into the bore, and it doesn't matter if it's perfectly on center line or not, but we'll put this business card between the hub and the edge of the block, and we'll slowly indicate that, not indicate it in, but move that until this business card has drag on it. Then what we do is we'll zero our Y axis, and we'll go the opposite way and put the business card on the other side until there's some drag. And we look at that number, and let's just say it's 1 inch. Or we divide that in half, so our center line is half an inch. Okay, makes it much faster when you're trying to align that with a dial indicator with a limited amount of travel. Just a little trick of the trade that we've learned over the years that maybe will speed your job up somewhat.
We also, every time we change the machine, we have to put what's called a 90-degree head on it. And there's a process that you go through to index it in. And that's a must. And once you get that down, it takes a little time. It takes experience. And you're not going to know it the first time. Because, you know, when we first got this machine, we had 4 days of training right off the bat. And the great thing about Rottler is they stayed with us constantly on the phone, in-house, whatever, to make sure everything was worked out and fine. It took us some time to get the process and procedures, the feeds and speeds. But I can tell you right now that we're so far ahead of the game from where we were a year ago that there's nothing that this machine can't do without your imagination.
When we're aligning the block, we're into what we call our set zero screen. And that's where we would zero our Y and determine the center line. That's where we would zero our Z, determine the center line there also. We go into our vertical stops, and that's simply clearance for, we've determined our zero or our center line, and that's what we're going to bore on. But once we're finished, the machine will back out of the bore, raise up, and move to the next bore. And all we're determining there is, as you can see, it says 10 inches block clearance. And all that is the machine's going to raise up high enough to clear the next main cap and then go back to the 0 point. We set our spacing in between our mains to where the right angle drive will drop in between each main cap and then travel a given distance to make sure that we get all the way through that cap. And then we'll back up, lift up, come over, and go to the next one. So we have line bored this block, and just to kind of show you, and I know it'll be very hard to see, but Logan or Embry, if you would throw that dial bore gauge in those bores and just kind of show us where we're at, or tell us a little bit where the sizes are at. But I think you'll find that it's extremely accurate.
What was our final size? 2 inch 9
36 and a half to 2 inches 937 and a half. So
we line board this block. It is 2 inch 937. We have 937, which is right in the middle of the specs. So, which is where we would like to put it, where it's going on the street. But all the way through this block, it is consistent and round. Each main is the same all the way through.
The one thing about this block that, since it had some age, the caps were twisted pretty good. The saddles were worn pretty good too, so it corrected all those problems, and that's just from age.
And would you venture to say, Logan, we're within 2/10 size throughout the block?
It holds very tight tolerance. We're within actually 1/10 to 2/10 on this block.
And that is a 10th reading indicator. That is not a half thousandths reading dial bore gauge. It's a 10th reading dial bore gauge. So we would see if we were more than a couple of tenths out.
Right.
It would show up much more dramatically than a half thousandths reading indicator.
Right. Yeah. Yes, it would.
One of the other things that I might point out is and this block, for the age, cleaned up very, very well. I was very surprised that we really have contact almost 360 degrees in the circle or in the diameter. But a lot of blocks will always grow at the parting lines, and so it is not unique to, after you line bore, or for that matter line hone, to see a shadow at the parting line. And I always get asked that question, well, is that acceptable? And I always tell them, if you're within, say, 3/8 to a half an inch of the parting line, and you have a shadow there, that's perfectly acceptable, because most bearings that I know of are thinner at the parting line than they are at at 6 and 12, and there's several reasons for that. But probably the biggest one is to make sure it doesn't wipe the oil off once the crush happens. You want it to crush out, not in. Well, I think that's just about covered line boring for today. I would love to thank Embry and Logan for their help and their knowledge of the process and all. If you have any questions or would like to have more information, please contact us. We'd be glad to answer any questions that you may have.
We are back live with Ed Kiebler and Chuck Lynch. Ed, you and Embry doing a great job over there, kind of getting us up to speed on boring versus honing, align boring versus honing, the heartbeat of the engine. Got Chuck from the AERA here, and this is going to be a great opportunity for you folks watching on EnginePerformanceExpo.com to submit some questions for these two guys, but we're also going to set up a little bit of a debate for them. So if you do have a question, put it up in the comment section. We'll hit them with it right now. But before we got started, we were watching the video as well, and there was a discussion about, like, what is the heartbeat of the engine? Like, what is it? Is it the align? Is it the crankshaft or camshaft? And I think there's a little bit of a debate. Ed started off.
Yeah, well, there is a debate. You'll get fellas, at least in our business, I'd get engine builders that say, in their opinion, the crankshaft or the camshaft is the heart of the engine. That's where you start from. And then you'll get fellas that debate, well, the main line or the crankshaft bore is the heart of the engine. And Chuck and I were just discussing a little bit about that.
Right, absolutely. With the crank housing bore, that sets your parallelism to your gasket deck surfaces, and so your control for piston height, that's going to control optimizing your compression ratio cylinder to cylinder, right?
Yep.
So, it's a good concept.
So we talk a little bit about, when we're talking about camshaft bore versus main line boring, one of the things that is important is that camshaft bore needs to be parallel to the crank bore. And that's another thing, and center to center distance, it's critical. When you're running either a gear drive or even on a chain drive, it's still critical to make sure that center to center distance from the camshaft to the crankshaft is the same, and that the cam bore or the cam line bore is parallel to the crank bore. And where that comes in is your lifter bore locations.
Absolutely. So, especially in the flat tappet world, which is quite a challenge, because if you have an out of parallel, actually a perpendicular condition, so we look at the convex on the lifters and the taper on the camshaft, well, now you're compounding a potential issue because the cam bar is not parallel to the lifter bore. So.
Right. And in fact, we get fellas that complain that, well, with the oils and all, I try a flat tapping and the cam goes flat like that. And it might not be the oil. It could be the perpendicularity to the camshaft,
Absolutely. We actually had Norris Marshall on our podcast, and we got into that conversation, and he said that was the biggest thing that he could do to fix flat tappet lifters or lobes going down, was addressing the issues with the lifter bore locations and parallel or perpendicularity.
Yeah, and explain just a little bit about that, Chuck. Maybe some of our viewers don't understand, but typically a flat tappet lifter has a crown on it. It is not flat.
Correct. So it's going to have, from the outside edge of the lifter, the major OD of the body, there's going to be a radius that is going to be a contact point on a taper on the lobe that creates the rotation. So if you have a lifter bore that is skewed in the block, then okay, all of those things can be thrown out. We could have edge loading, and then that really is going to accelerate the wear.
The minute that lifter doesn't rotate, you're toast.
Correct.
Yeah. So you have to have lifter rotation in order to keep from causing a lifter or a cam lobe in a flat tappet to round up and go flat.
Absolutely.
Now, oil's also a big issue, but it's not just the oil. Kind of like Lake always says, it's the soup.
It's the soup. That's what Lake, everybody's going to take that out of Lake Speed. It's the soup.
Yeah.
All right, guys, we got a couple of questions out there. Want to remind everybody, if you happen to be thinking like, hey, man, I don't know when I can click this off, right? The answer is never. You got to stay on live all day long. John Kazi, Hidden Horsepower Live, just minutes away, so stick around and let some folks know. But we got some questions out there. For instance, like Mike wants to know, how do I get a copy of the formulas that we've run through on the whiteboard rather quickly? And that's why this is so great, because it is going on the internet, and you'll be able to watch it and pause it and rewind it and copy it and all of that. There might be additional resources where we put those out, but it's on the web, and you'll be able to go back and watch this over and over again. Next question, this one coming from George, regarding the aligned boring and honing. How do you deal with the rear seal bore, is a question.
Oh, okay. I assume he's talking about like on a small block Chevrolet, or maybe even a small Ford. A 400 small block where the seal area is maybe smaller diameter than the main area.
Right.
And when you're line boring, it's a simple process. You can bore that out to the same size, or you don't have to bore that at all, because what we're really doing on a small block Ford or a 400 small block Chevy is we're just boring the mains. We're not touching that seal area, so you can leave that seal area alone. If you're line honing, then that seal area is going to have to be cut, and then I believe, and Chuck, you would know this, they make a specific seal to make up for that rear seal on a 400 small block.
Right. And AERA, I think we have a bulletin that's got some listings of alternate seals for applications like that, because you're right, oftentimes people will go and bore that area out just to alternate and go to the different options so they can align.
Yeah. So that's a great point right there. If you have questions like that, technical questions, you need specifications, AERA is a great place to get that information.
And as a podcaster, Chuck's podcast is really good, loaded with information, and we're going to be hitting you with stuff all day long. Look, check out this, go to that, sign up for this, etc., and so on. Just be ready, because it's all great stuff. Jonathan wants to know, is there a 90-degree boring attachment available for a vertical mill?
I honestly don't know that. There may be, there are probably 90-degree attachments, but it's more than just a 90-degree attachment. It really has to be a precise tool or a precise piece of equipment, because we're talking about tolerances of 2/10. We hold size to within 2/10 straightness and roundness on a line bore. So it's a really precise thing. I suspect there are some 90-degree boring heads that you could get.
There definitely are.
Yeah.
And then, but again, to your point, getting it indicated in and trammed in, because you're going to make an outer round bore. If you don't have it trammed in and you're not making a round hole, you're going to make an egg shape as you pass through the part.
That's a great point.
Being able to tram that in and understand indication of that. I take it off once and I try to put it back the next time. You have to spend all of those efforts again trying to get that aligned.
Right. And what Chuck's talking about alignment is it's not just the main bore being in line with the axes, but that right angle drive has to also be perpendicular to that bore. If it's not, as Chuck says, you'll end up with an outer round hole and be scratching your head and wondering why.
And these are the details that cause things to go, I don't want to say slowly, but methodically. Like in the end, if you've got someone that jumps ahead or skips ahead or just send it, you can end up with big problems. And that's why the whole machining engine building world, it's a bit of a slow process, because would you say 2/10?
2/10.
2/10.
Put that into perspective, Ed. I know you did a tech talk last week in Dallas for the NHRA, and you were talking a little about the size of a human hair,
Right.
versus. These are
Exactly.
minor measurements.
Yeah, the best way I can relate that is that your typical human hair is 3/1000ths. Okay, we're talking 2/10ths. So if you put that in perspective, what is that? That's 15 times smaller than a human hair. So very, 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 very precise part of the engine, and as Chuck was saying, is it's the heart of the engine. It's where everything starts. It's where your compression heights are set, and your oil, like a dart block or the aftermarket blocks where you've got the primary oiling. All of that starts down there in the main board. So
Right, it's a master datum. If you got a map, you need a legend and you need a starting point, and so everything has a master datum point, a point of origin, and,
Yep.
and that's kind of where we're looking at the crank housing board.
yeah, and typically what we do is like you said, is when you're machining a block, it all starts from down there. So we want the line bore to be perfect, and that way everything from that, your cylinder bores, your deck heights, your lifter bores, anything, your stroker clearance, and all is set from that datum point or that main bore.
No, I love the map analogy. I think we've all been in that situation, or certainly those of us who were live before GPS navigation have used a map and understand that focal point. The AERA has got a lot of great stuff going on. Ed, you're going to be back throughout the day, as will Chuck. So if you didn't get your question answered in this session, there will be more throughout the Engine Performance Expo. And those of you watching on EnginePerformanceExpo.com, think about it, write them down, and we'll try to revisit from time to time as we do these live Q&As. Gentlemen, excellent work. Appreciate you. And we'll have you back not long from now, and we'll keep on going. But this has been a great start.
Thanks, Joe.
Thank you, Chuck Lynch, Ed Kiebler, and they are going to be back throughout the episode. What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.